Okay, welcome. Thanks for coming. I know it's always tough, several days into a conference, a lot of exciting topics to talk about. So the first thing we're going to talk about is governance, kind of positioning of the product itself. And then we're going to talk about the vision, some features, some roadmap items, and we're going to get to the more exciting stuff. Venkatesh is going to talk about the architecture. He's going to talk about what is it, how does it work, and other pieces regarding the architecture. So by way of introduction, this is Venkatesh. He's the principal architect for Apache Atlas. He leads development. He was originally part of the Hadoop team at Yahoo, where he built data management solutions. He's been involved with Hadoop and has contributed to many open source projects in the ecosystem over the last 7 years. He's been really busy, and he's awesome, and he's been really the driving force behind Atlas, so we're very lucky to have him today. My name is Andrew An. I'm the Director of Governance. I have the honor of working with Apache Falcon and Apache Atlas, right? So I guess we'll get started here. I think people are still filtering in, so this stuff isn't quite as important as maybe the next slide here. So for those of you who might have seen some of these slides in the past, I apologize. I'll try to make it exciting and quick. So this is just a positioning statement, so I won't spend too much time with this. But the idea is that, in a modern enterprise, there's a lot of activities that need to be done, right? And governance really is a set of standards you're taking care of internally to meet an external test, right? Whether that be some body or some standard, whether it's the SEC or PCI, right? So you really want to develop these internal processes to meet an existential test, right? And while you're doing this, you need to take care of, a couple of housekeeping items, and I kind of bucketed them into 4 large areas. And you can divide these into more buckets or smaller buckets, but essentially these are the commonalities, right? So your processes have to be transparent, they have to be reproducible, they have to be auditable, and they have to be consistent. You can't randomly decide to do things differently, because it's a particular day of the week. So that kind of sets us up for this slide. What we want to do with Hadoop is make sure that it has reached a level of maturity and stability so that it doesn't matter what platform it is in the context of the larger ecosystem, right? It should be just another part of your enterprise data ecosystem, right? And to get to this level of maturity, one of the things that we've done is we've partnered with a number of customers to help build out the product. A lot of times when you start a new project or a product, especially in the open source community, sometimes you don't have that clarity or the ability to make use of the thing that you're building right away. So the idea is we're partnering with these really helpful co-development partners to actually build out real use cases, right? And in doing that, we're able to build out the proper capabilities so that we can immediately get value out of what we're building, right? So we don't want to wait for several versions in to actually get something out of it. We want to get time to value in an expedient way, right? So really, we're driving the capability in the direction of the product based upon, our customer feedback, right? So these customers are not just starting out with Hadoop. They've gone well past the POC phase, right? They've deployed Hadoop in a small project, and they found value in it. Now they want to leverage that further. One of the barriers to getting more data under management inside of Hadoop is basically controls. They don't have the controls that they need, right? And that's what we aim to address. Okay. So quick overview. So at the heart of Apache Atlas is really our metadata services, right? We have a flexible knowledge store, which we'll talk about in detail. Venkatesh is an expert there. We're able to provide business catalog services, operational data. We can provide search and a proscriptive lineage. I put it in red so I wouldn't forget, and I'll talk about it. Hopefully I won't forget about proscriptive lineage. And we want to centralize all this metadata within HTTP, and then we want to be able to make sure that external sources can consume this and exchange data with us, right? And that's really the effort there. So, inside of the Hadoop stack, there's 26 components or so. It's hard to unify that and marshal that to meaningful sets of services. So what we want to do is we want to provide metadata services to kind of unify that and coordinate that activity, right? So just a kind of a quick example. Out of the box, we're going to ship a Hive component that's going to allow us to track lineage, right? So for Hive, we're going to be able to get complete lineage. We're going to get every SQL query that was run on that. We're able to stitch that together to give you proper lineage, right? That's what you get out of the box. Very, very soon after that, towards the end of July, we'll have Ranger integration. So we'll be able to have attribute-based policies. So this is a fundamental change from the way policies have been written before with Ranger, where it's role-based. You're part of a group, and you get access to this bucket of stuff. Now you can create an attribute-based policy, right? Your data curation group, your data steward can take a look at your data and tag something sensitive, and then you can have a policy for that sensitive data, right? So you're able to decouple them and really scale, right? The data curation folks can do what they're really good at because they know the domain, and the policy folks can just make sure that the policy is taken care of. And this is really the only way to scale in a meaningful way, right? And Falcon, we're going to give Falcon the taxonomy and the controls with those types of structures that it currently doesn't have, right? So we're really going to extend that. So this is just by way of example of what we're trying to do here. So, Apache Atlas is going to be able to connect to every component. We're going to start off with these 5 for this year, and this is all driven by, customer input. And then we're going to extend out and cover the other components. So when we're done with this, we're going to have most, hopefully all, of the components writing metadata and giving us that great lineage, and those additional metrics, right? So I'll just jump to this slide in the interest of time. So here's a quick overview of the capabilities of Atlas. Now, I should throw a disclaimer out there saying, you can use metadata for any purpose. These are some of the ideas that we had in terms of designing the product, but there's a lot of novel ways to use the types of data that we're storing and collecting. So actually, I heard quite a few of them today, so thank you if you're in the audience for those suggestions. So data classification. I won't bore you to tears with this, but basically, this is a classification from a business perspective, right? So that's where we're rationalizing that operational data from a business context, right? So in terms of having like really cryptic names for files or paths or some other streaming topic, you're able to have business names, right? Whether it's a store and a product, or if it's a type of vehicle and it's a truck, those things, those business classifications can now be represented any way you want. So they can represent a file, they can represent a table, or a Kafka topic, right? So the idea is that we're connecting them together so that when we actually do audits and when we look for data and you need to discover data, you can do this in a more meaningful and effective way, right? Can you use this for an MDM type solution? We don't explicitly say this, but of course you can, right? It just depends how you deploy it, right? Centralized auditing. We're going to capture basically audits and logs from the entire stack. We're going to implement this probably in Q3, so that's coming really soon. But the idea behind that is we're going to relate the business data and all this, this very valuable metadata structures that we've created, and we're going to link them to the operational data, and that's coming really soon, right? Search and lineage, pretty obvious. All the components inside of our metadata store will be searchable, and we'll have lineage attached to it, right? Venkatesh will talk about the underlying technology around it, the fact that we use a graph database, and we're really good at defining relationships. So we can overlay many models. You can create new attributes on the fly. You can do all kinds of really cool things, right? Oh, I went backwards. A quick word about the type system. Venkatesh is going to talk to you at length about what the type system is, but I just want to underscore what that can do for you in a business context. You can create any model that you may need to model your business. So for instance, to model retail, it's very different from modeling the energy sector. One has product stores, customers, inventory. The other one has like well sites and really exotic, really cool tools to do sideways drilling and all these really neat things. But the way the business is run, the types of revenue streams, the cost, they're modeled totally differently, right? And if you look at the top, we have a bunch of different types of verticals that we're working with, right? So rather than trying to model all of those types of businesses and also trying to model all the different components in Hadoop and making them all work together in this really huge undertaking, what we've decided to do was build something small and agile. So this flexible type system allows you to do that. You can create different types of objects, and you can have cross-cutting traits that allow you to link them together in meaningful ways with relationships. And Venkatesh will talk about that in great detail. So basically, instead of building Noah's Ark, we built something small and agile. We built a replicator to build just the right thing. And it's very significant because we can model any business, but we can also model any tool. So if you're already using a metadata tool, we can make our structures match that tool so you can import tools in an easy manner, right? And you can export them in the same way. And that's something that differentiates us from our competitors, right? So we're not talking about a point solution with a specific application. We're talking about the whole ecosystem. We're trying to get visibility into all of Hadoop for the external consumers, right? We want to be the metadata truth in Hadoop, and we want to integrate with as many consumers and outside groups that we can, right? Okay, so with that, I think we can jump to the side. So what can you do right now out of the box? So this is kind of a common use case. So this just illustrates how you'd actually use Atlas, right? The idea is that, and we've actually deployed this with a couple of customers already. You have a traditional database, and you need to offload it, and you want to get it into Hadoop. Well, what we can do is we actually have a custom scoop component. We're in the process of getting it released into the project in open source. But for now, we're using a load wrapper, which can, by the way, be a Falcon process. So it actually performs this ingestion, right, some kind of JDBC connection. We're able to get metadata, and we're able to create annotations. We're able to create entries into Atlas, right? So we're able to track that. And then once it gets in, all the additional SQL that's run against that data set, we're also tracking it automatically because we have these hooks into Hive. As I mentioned in a previous slide, you get that out of the box. You get that Hive connector, right? And then there'll be a further process, let's say, and you do something else in Hive. Well, all those things are represented by those dotted lines, and they go into Atlas, right? So now we're able to track that. We're able to give you back lineage. So that helps you, establish maybe some troubleshooting operational benefits. But what else can you get from that, right? The benefit is that because we know the exact SQL that was run, we know the direction, right? We know the source, we know the target. If you do some kind of alter table, we're able to track that too. So we can actually version schemas, right? And because we have that business data, now you can search by some, cryptic table name or the type, which happens to be a table in this case. But you can also search by the business context. You can say, I want to get that, truck, model XYZ, and you can pull up this information, and then you can be directed to the appropriate asset for those purposes. Additionally, a curator can go back and see this workflow and then annotate it with other types of information, like, is this column sensitive? You can tag it PII. And then later, we'll talk about the integration we're going to have with Ranger, where we can create that policy-based rule that says, if this table is tagged PII, allow certain groups to access it, right? So we're able to get that additional sophistication, right? Actually, let me talk about one last thing before I go. In terms of the policy engine, I kind of glossed over this, and I would be remiss if we didn't talk about this. So in July, we're going to have Ranger integration, and as I mentioned earlier, but there's different types of attributes that we're going to support out of the box. We're going to support geography-based rules, which means that we'll understand where you're coming from in terms of a user, right? So if Venkatesh is accessing data from the United States, and he's able to get access to it, he jumps on a plane and goes to Switzerland, he may not be able to get access. And the reason why is Switzerland has different privacy rules. So we can evaluate the location and use that as a part of our dynamic access controls, right? The other thing that we can do is we can base policies based upon time, right? So, those of you who understand a lot of these SOX reporting requirements understand that there's a 90-day reporting requirement for violations. So, it might be helpful if you can stop certain types of access at 89 days. So although they can pass all these other checks to get access, you might want to have this aspect override access to that data set, right? So it's actually pretty significant because you have a lot of control. So if you have a long-running process that's been running for 4 days, you don't want to just pull the rug from under that process and delete the file. What you really want to do is you want to stop access, right, and prevent new violations. And that's just the beginning. We have a lot of other things that we're developing to make that more helpful, right? So I just want to touch upon that policy aspect of it, right? And lastly, I want to talk about this slide, which is our governance ready certification program. I'm kind of glossing over a lot of these topics because I know that you guys want to talk about the architecture and peek under the covers. This program allows us to do something really meaningful with that metadata, right? So you've done all this hard work collecting that to maintain lineage, get chain of custody to make sure that the right people are accessing the data in the right way at the right time, right? So what else can you do with that? Well, why not plug in other applications and have them get value out of this metadata? As I mentioned earlier, we want to marshal and unify, the stack by providing, common metadata services, but we also want to do this for all of Hadoop externally, right? So some of these types of activities, Hortonworks, it's really not suited for us, right? We are a platform company, and we want to innovate at the core, right? So are we going to provide better visualization services than a number of packages you probably already own? And does it make sense for us to develop software to do that? And the answer is pretty much no, right? So there's a number of these types of activities that everybody in this room probably has to engage in, right? Discovery and tagging, prep and cleanse, ETL stuff, self-service, and visualization. There's more buckets, but you get the general idea. Why not have all of those discrete applications actually get their information from our metadata store? Right? So the discovery and tagging operation can create tags and give you, pretty good identification with, boilerplate PII type stuff, right? Address, name, phone number, zip code, that type of thing, right? Have it write to the metadata store, and the next process that might do the cleanse operation or some ETL, it can actually learn from that, right? It can learn from those tags and do something meaningful to it, right? So although there isn't discrete interfaces between those packages, they can work together, right? And so to get this governance certification badge, they need to do a couple of things. They need to promise to be good citizens. They can't keep data in proprietary formats and basically hold it hostage. There's going to be an SLA associated with that, right? If you do something to that data, to that payload, you have to report that, right? Just like all the other components that we talked about in the previous slide, it will apply for those vendors as well. So that's basically what I wanted to get across in terms of these additional things you can do with metadata, right? So low switching costs, right? Customers can pick what they want to use. They can pick a la carte, right? And you can take a look at really new and innovative features. So in sum, we really want to create and foster an ecosystem where we're really advancing innovation, right? You don't have to buy this really big suite of tools for like 10 things that you may not like for the 1 or 2 things that you really need, right? You can pick and choose what you want, and you have that control, right? Okay, so high-level roadmap, and then I'll turn it over to Venkatesh. I think I'm over time. So we released a minimum viable product into ASF in May, and that's when we incubated the project. So Apache Atlas is a podling. And in a few weeks, we will be releasing HTTP 2.3, and it is GA. So in terms of feature set, it's the same as our MVP. However, it's been hardened. We've done lots of testing against it. In M10, and that's what I referenced earlier in terms of July, we'll have the Ranger integration. That's where we're going to have that attribute-based control, and we really start to get dividends from that metadata, hard-won metadata that we've been collecting. And in M20, we're going to get these connectors to Kafka and Storm, right? The governance certification process will probably be in place in full swing, probably before, but we'll see. And then we'll have this other thing where we're going to preview row-level masking. We don't have the time to discuss that, but you can reach me after the session, and I'll be happy to talk about that in detail. And at the end of the year, HTTP 2.4, all those preview features and all those items will become GA, right? Right, I'm going to hand it off to Venkatesh.
Okay, thanks, Andrew. So at a high level, this is a stack. It's pretty simple, and at the core of it is the type system. We keep saying, type system, type system. What exactly is a type system, right? In a relational world, you work with, already specific types that we are aware of, right? There is a database, there is a table, there are a set of columns for a table, right? Database and table have some lifecycle. Columns don't by themselves, right? They belong to your table. You have partitions, right? In the relational view of Hadoop, you also have, storage descriptors, specifically Hive. When you switch gears to streaming, you have different abstractions there. So how do you actually, represent those designs, if you will, right? Storm has a completely different type, if you will, right? The topology, the spouts and bolts are types essentially, right? You want to represent them and visualize them. How did the data flow through this DAG, right? Cascading has a different, taxonomy completely. How do we actually represent these different, things within the ecosystem and make it, work across for provenance, lineage, all the common, cross-cutting concerns in a governance context. So we came up with this, very generic type system, and you can actually express your meta models from your domain, both from technology perspective as well as business perspective, and create them as types within the type system, right? It's pretty simple. We're going to look at some examples, so if it's abstract, it'll become clearer. And all these types and associated, instances of types, what we call entities, like you have a table, you can have, clickstream table, impressions table, yada, yada, yada. All that could be, is stored in a repository, and we use graph database for various reasons. And, you would never interact with the repository. It's completely abstracted out. We have a search DSL, which is very similar to SQL. We're going to see some examples as well. You could, we've kind of killed multiple birds in one shot. You can search through entities. You can also, look at lineage, provenance, all that using, search. And we also have higher layer APIs for specific components within the Hadoop ecosystem, like Hive, Storm, which we're going to see again some examples. And everything is REST-driven at the top, right? We also, the search is integrated, through either Solr or Elasticsearch. It's configurable. We also have this concept of bridge. If you have existing investment in, let's say Storm or Hive, we provide a bridge to import all the existing metadata so that, Atlas can start working from day one. If it's like a discovery mechanism, it's pluggable. If you have a system like Adaptive or anything else in your organization, you can write a bridge, discovery bridge, to actually go discover your business metadata and suck it into Atlas. It's extensible, and we will ship bridges for all the components within the Hadoop ecosystem, and we'll work with partners for other things. So the knowledge store here is a Titan graph database. Backed, the persistence is backed by HBase by default. It's pluggable. We chose Titan because if you have arbitrary entities and you want to correlate them, it's very hard in a relational, modeling that in a relational world. So it's just easy to enhance the relationships across entities. Like you want to call, you call something as sales in your technical metadata, but you call profit and business metadata, correlating them, and adding relationships between those two is much easier, just adding to, and a new edge between two vertices, right? So that's the reason we chose this. As I said, it's pluggable search backend. The rules engine, we're working with Ranger team to actually figure out what it would be. But this time, it's a very simple expression. The Audit Store is not Yarn ATS. We were evaluating, but it'll be a completely new one. Dashboard is very simple. We use, Bootstrap and Angular. Sorry, it's outdated slide. Yeah, we'll skip this. So types in the type system, right? We essentially have three main things, right? One is a class which has identity. You can model anything in your domain which has identity as a class. It's very simple. You have a set of attributes in a class. So a database is a class, or a table is a class with name as a string. We support all the primitives, backed by Java primitives, of course. And structure a bag of things, right? It doesn't have its own identity. Like, a storage descriptor cannot live on its own, right? So it will essentially be a struct. You will have what's your input format, what's your output format in the Hive context. So you can define that as a struct, and you have, we also support traits. Think of traits like tags, right? So as Andrew was saying, you can model your business taxonomy as trait. We support type inheritance as well. You can have measures, right, like claims. You want to have data quality measures on your data, and you can either have that as a trait. So the measure would have some attribute which says, what's my variance, right? What's my max, what's my min, and what's my variance? Or you can have security clearance for an employee, right? You can have security clearance on a level. The level could be an enum, which is 1 to 5. So at runtime, or somebody decides this employee has this security clearance level, right? Or PII information. PII could be modeled as flat, which is SSN PII, or you can have a PII information, have an attribute which specifies what type of PII is that. Is that a social security number? Is that a customer ID, a customer address, or email, what have you, right? So this is something that is bare bones, which you can construct any model that you want. We also ship out-of-the-box models for all the components within the Hadoop ecosystem. We support collections, map and array, and you can create instances of classes using something called referenceable, which we're going to see some examples. So this is just a UML diagram of the data types, just to show it's pretty extensive. We can pretty much model anything. This is Scala type builder, which is pretty cool in my opinion. We have a Java API as well. For everything, we have both Java and Scala API. We will have a UI to model these things in the future. So you're creating a dimension, right? I mean, if you have a dimension data, right, customer, time, product, all different dimensions, you can actually tag or associate a trait called dimension. If you have fact, you can have a trait called fact. If your column is PII, you can have a trait called PII, ETL, JDBC access, whatever. Now you're creating a database class, right? So this essentially is a type that you're defining within the system, saying a database will have a name. It's a string. It's required. It has to be indexed and unique, right? So the indexing is also an annotation, right? By default, it's true. But if you want to turn off indexing for certain attributes within your type, you could do that. You have that control. So there is also owner and creation time, right? Storage descriptor, it's very simplistic in this model, just to drive home the simplicity of the API. There is input format and output format. Both are strings that are required. The column here is essentially, again, at another class, because columns could be removed and added to a table. You have column has name, data type, and storage descriptor, and table essentially is a complex type. You have database and storage descriptor as references here, right? So you could have a basic type or a composite, right? And you can have composite to have, you can define the lifecycle. Is the composite reference, or it's a full object? So that means when you retrieve a table, if it's a composite, then the whole database definition also comes along, right? It depends on how you want to treat it. You want to have database and an array of tables, or a table referring to a database, right? And you can have IDs returned, or you can actually, based on the annotation, whether it's a composite, you can return the entire definition of the database as well. So repository, I think I covered this, but essentially, it's a graph database. All these types and instances are stored in the graph database. We don't use any other component in the Hadoop ecosystem. So essentially, classes and structs, they're all mapped to a vertex. Trait is a vertex in itself, and whenever you associate a trait with a class or a class, essentially there is a relationship. There is an edge going out from the trait into the class, into the class vertex, essentially. And indexing is, again, as I said, based on type annotations. You can, by default, everything is indexed, but you can turn off indexing for certain attributes, if you will. So search, right? This is the kind of critical part of this whole thing. It's very, very SQL-ish, but very simple to explore different things. You can have from table, right? I mean, you will get a list of tables, all the instances of a table in your repository. Right? You can do where clauses, right? You can say where name is reporting, and you can select certain attributes of the type. And you can also say, give me all the databases that has an attribute name that is not null, right? That is, so DB has name, right? Will return essentially all the databases that has name populated. DBE's JDBC access is a trait search, right? This is like, give me all the databases that has a trait or a tag called JDBC access, right? You can have certain databases that are dumped, from Scoop through JDBC. You can have, other native, tools that you use. So you want to tag these different pipelines with different traits, and you could do trait-specific searches, right? So this is a join table where name is sales fact, comma columns. So you get all the columns for a table whose name is sales fact, right? We also support, we're going to see Lineage in a bit, but we support full text search as well. Lineage here, right? I mean, it uses search DSL expression. I don't know how many of you know Gremlin. Gremlin supports this, it's a DSL for graph database. It supports this loop construct. So you can basically start with a vertex and an edge and keep going until you iterate through those edges. So we use that to actually solve Lineage problem. It's essentially we provide for Lineage higher layer APIs like inputs. Give me, if you want to do provenance or Lineage, right? You want to see how did this data come about in the system, right? So you have a sales data that was dumped by a scoop job, from your EDW, right, Teradata or whatever. You want to see that this was actually a fact table that coming from Teradata through a scoop ingest process, right? So inputs essentially give you that. So it basically is a complex SQL query, but we have these named queries and expose them as APIs, which translates to essentially, which we're going to see an example and which translates to this query. Outputs is essentially impact analysis. If I change the schema on this data, right, or if if the SLA of this process is not met, what is the impact of my downstream, right? This is the impact analysis you want to do. What are the outputs from this data or process or this entity going out till the leaf, right? And outputs give you that. So schema is essentially, as I said, for table we expose a higher layer API, which is essentially a join in the SQL. Or in DSL. So I spoke briefly about this in the bridge concept. For Hive, we provide both a bridge, which essentially, if you have an existing installation of Hive, in your organization, we provide an import tool which imports all the metadata definitions. We also ship out-of-the-box model for Hive database, and we suck up all the metadata definitions so that you don't have to start from scratch. We also ship a hook, post-execution hook for Hive. So that means every query execution is intercepted after after it's processed, and it gets the query text, the time, the start and end time, the query ID, and most importantly the logical plan. Right? We extract the complete plan, but we are extracting out of the physical plan a logical plan and keep a graph of what joins were done, what were the predicates, right? What was the scans done for each of them? What are the filters used? So you could do, eventually, once it's baked out, you can do pretty interesting analytics on the metadata itself, saying, give me the most used filter on this table, right? Or give me all the tables that have more than 6-way join, that participate in a 6-way join, right? Things like that. So essentially, we are trying to enrich all this information and keep it here, and it could be used in, different, meaningful ways in the future. This is, by the way, shipped as part of the MVP. This is dashboard.
Yeah, I'm going to go through this and give you a little break. I guess I'll speak loudly. Keeps me awake. So basically, I'm going to go through some of the screens because we weren't brave enough to do a live demo because the Wi-Fi connection was a little bit flaky. But basically, what we're doing here is we're showing you exactly the types of searches. Thank you. Thank you. Doing the searches that we talked about earlier, right? So that's a DSL, and it's just going to give you basically the results of your search, right? So you get these different tables that were available. On the left side for you, you have a bunch of tags, and the UI is probably going to look a little differently when it actually ships, but we just want to put some tags in there. And this is going to correlate to the example that Venkatesh talked about. You have dimension, ETL fact. I don't know if you were paying close attention, but basically those are the traits that we define. And here we're searching for PII. So it's saying, hey, look, tell me all the columns that have sensitive information, and we're able to provide that, right? What else are we keeping? We're keeping the schema, right? As he mentioned, we're able to track this stuff. We're showing you details about that, creation time, the owner. And now this type of information we can annotate with additional attributes. So this is where the business overlay can happen, and we can add more business classification to that, right? And here's some of the inputs, right? So we show you a lineage graph, right? And you can actually hover over this and get information about these objects, right? If you hover over the load process, you'll actually get the SQL that was run, right? So do you want to talk about the class demo?
Yeah, so this is essentially the example. I mean, it's as backwards here, I'm sorry. For just the demo purposes, we created this type. So essentially, it's very simple, relational database. You have database, table, you have a storage descriptor, columns. We have, views. The load process, essentially, think of it like query execution, right? Then we have a bunch of traits, right, that we associate. This is essentially the type that we have defined. And this is the instance graph, right, the entities. So we have two databases, sales and reporting. Sales has 3 dimensions. One is the time dimension, product dimension, and customer dimension. And you have a sales fact, right? And there is a daily load process which runs, which takes as inputs both the time dimension and the sales fact table, and joins and creates a summary table, a daily summary, right? Which is what is in the reporting database as sales fact MV and daily sales fact MV. And then there is one more process which takes the daily summary and the time dimension and creates a monthly summary, right? I mean, you can have weekly, monthly, yearly summaries, right? It's pretty simple. So, and we have some traits here. The customer address is PII. All the dimension tables are tagged as dimension. The load process, is ETL process, things like that. The views are essentially JDBC access, right? So that's the kind of example, and this kind of walks through that. This MVP that we have walks through those examples. So the traits are actually coming from the types that have been defined, the tags that have been defined in the system. Eventually, we can do fancy things like show the top 10 with number of hits and things like that. Okay, questions?
Yeah, thank you. All right, so in the interest of time, we'll try to take a few, and then you can talk to us after the fact. Yes, sir.
Well, to make the data slide, sounds to me like this is HKTalog on steroids.
No, HKTalog was meant, I know how HKTalog was born, but HKTalog is more like an API on top of Hive.
Can you hold on for 1 second? The question was, is this like HKatalog on steroids? Right.
So HKTalog was initially meant to provide table abstraction for any data in Hadoop. It never went there, right? But what it did was to give you the table abstraction through Hive for other components like Pig, MapReduce, right? Could now use HKatalog to actually work with table abstractions instead of raw files and directories. Because partition completion, notion of partition completion, all that is very hard on HDFS to implement, right?
Same thing we've done here, right? So processes or applications can leverage Atlas to explore the schema of the data and then be able to interact with the data.
But HKatalog was limited to Hive because it uses Hive Metastore in the backend. Here it's very open-ended.
Yeah.
We don't actually limit to Hive, but you could do Storm, Kafka, anything else, right?
Yeah. If I can just kind of interject there, the other difference between
I can say HKatalog done right. Let's be.
Yeah. Well, the idea is that it's not limited to Hive. We're supporting all these other components. We're going to start off with those 5 that I showed you earlier, but we're going to get the whole stack in terms of that integration of getting that metadata. It's going to be a service that's going to be common to all the other components. That's really what we want to focus on. And the additional piece is that now we can overlay the business classification, that taxonomy with the relationships. If you've got to do something like a PCI certification, you can start off with the vocabulary that you're using for that requirement. So from the beginning, you're tagging data correctly. And then the hierarchical structures are already in place, right?
Yes.
So, who was that? Yes, sir.
So, what are you guys doing with the data that's already in HKatalog?
What are we doing with the data that's already in HKatalog? And the answer is...
I mentioned HKatalog doesn't have its own repository. It uses the Hive Metastore. We have a bridge into the Hive Metastore. We are sucking up all the data.
Yeah. And that is shipping. That was a part of our MVP, and that's shipping with HTTP 2.3 in like a couple of weeks. Yeah. And that's actually, we stole Venkatesh from actually working on bugs because we had to give this presentation, but he's actually going to go back and help us finish, get those bits out. Yes, sir. Standard deployment for the metadata store. Dev to production, okay.
We have Ambari integration as part of the first release if you use Ambari. If you don't, it'll be available as a tarball release by end of this month in Apache.
So are you talking about a way of segregating, the metadata you would store for those different environments?
So for if I just define metadata in one environment, would I be able to exploit that?
Oh, yeah.
Yeah, we have bridge capabilities from different environments of Atlas, yes. Yeah. Okay, we have time for one more question, and then, we can take questions offline because I think they need
Yes,
to get ready
sir.
for the next presentation.
It's Hortonworks.
Well, that's a kind of a complex answer. Like, no one actually can give you a product to give you PCI. You actually have to work with a third party to certify the installation, not the tools, right? So, like I mentioned earlier about the governance, the existential tests, that's one of those existential tests. And you have to make sure that the practice is done correctly. So we can facilitate that, but we can't give you that kind of certification. Right? So thank you very much for your time. We really appreciate it. I know it's... questions.